Okay, so are you seeing my drawing here? Not that great a drawing, but I hope you understand what I'm trying to represent here. Okay, so you see this is what is represented with an eye that is untouched with the natural lens, right? So when this cataract surgery is performed, what happens is that the lens is taken out. Okay, so you don't have any more lens in there. Okay, and what happens is that your cornea, right, if it has astigmatism, then it has two different focal points, right? And why I show the focal points, it's a little bit way back here because there's no lens that is in place, all right? So when you choose a IOL implant, when we choose a IOL implant, oops, okay, and we put an IOL in there, what we are attempting to do is to correct the refractive power of the eye and bring the focus point forward. Okay, so when we are doing this with a regular monofocal implant, so what you can see here is a calculation, right? So when we are calculating a monofocal implant, what's happening is that we are using the K values over here, right? But we're not using a specific K1 or K2 value, but we're using the K average value, right? So somewhere between, so in the middle between K1 and K2. So we're using the K average to perform the calculation, right, to give you an IOL power like this, 21.5 diopters. Okay, so this is what we're going to get over here. All right, so let's say we put in 21.5 diopters of a monofocal implant, non-toric lens. All right, so what happens is that we're not correcting the astigmatism, but because we are using the midpoint of the two K values to perform the calculation, effectively what happens is that we bring the focus onto to as close to the back of the eye as possible, but neither one of the focal points is on the back of the eye, but rather the spherical equivalent power, right? So that is why when we look at the calculation here, right, this is always referred as the spherical equivalent outcome, right? And this is the spherical equivalent IOL power that we're putting in, right? So when we are using a standard monofocal lens, we're not correcting the astigmatism as in bringing the two focal points into one point, but we are using the spherical equivalent, right, to get the best result, right, without using a toric IOL. Okay, so like we said earlier on, you can use the spherical equivalent effectively, right, to correct the vision if provided the astigmatism is not more than 0.75 diopters. And if you look at this case here, the astigmatism here is actually quite significant, right? To take the difference here is actually 1.62 diopters of corneal astigmatism. So that's actually quite significant, right? So using the spherical equivalent power may not be perfect to correct the astigmatism, because this gap here that you see here is 1.62 diopters. So that gap here, it's a little bit too much, right? And you won't get a very good clear vision. All right, so what is needed is then we need the toric lens to correct the astigmatism here. Okay, so if you think about the cornea power here and the IOL power here, that means to say that the K value, one of the K value, right, the flatter part of the K value plus 21.5 diopters, it's too much power. Okay, too much power. So sorry, this one is more steeper. So this cornea power, which has more power, plus 21.5 diopters on the lens, has too much power. Okay, on the opposite, where the cornea power is lower, okay, when you add on that cornea power to 21.5 diopters, that is too little. All right. So that this 21.5 diopters is too little for a certain power of the cornea, and it's too much for a certain power of the cornea. All right. So when we choose a toric lens, like so probably in this case, you may choose let's say a ZCT to 225, right? Okay, so when you choose a ZCT 225 lens, okay, what it means is that you're adding 2.25 diopters, right, of cylinder power onto the lens. Okay, so what that means is you take 2.25 divided by 2, so that gives you, I think it's 1.175, right? 1.175 on either side. Let me do a calculation. .125, sorry. Right, so it's 1.125 on either direction. So actually for a 21.5 diopter lens, that is actually equal to a lens that is 22.625, right, on one axis, and on the other axis it is running out of room to write here, 20.375 diopters. Okay. All right. So the lens, when you use a toric lens that is ZCT 225, right, it means that you have a little bit more power on one side, right, and a little bit less power on the other side. So what that's going to do, if you align the lens correctly in the eye, what it's going to do is it's going to be able to bring your two focal points, right, much closer, right, much closer together. Alright, so toric IOLs help us to correct the astigmatism, right, by giving you two different refracting powers on the lens, right, to bring the two focal points closer together. So if we look at the toric calculator, So if you look at the toric calculator, so I put in the example here. All right, so we put in the K readings. Flat K reading, it's the smaller value. Steep K reading, higher value. And remember to put in the axis. So how do I get the numbers here? All right, so basically I took the numbers here. Flat K, steep K, and then I think the axis was represented at the back of the K sheet. So the steep K 45.62 is at 19 degrees. So I put in 19 degrees here for the steep K, right? And the flat K is opposite of that, 109. Okay, and then this is the calculation that is derived. Right, so you need to put in the axial length as well. Axial length indicated over here. Alright, so I'm taking the immersion method of our biometry using the axial length 23.14 millimeters. And here, method of the biometry, so you can either choose, so what I choose is optical or immersion, which is the same value of 119.3, right? Spherical equivalent power chosen, 21.5, so I'm just assuming it's this value that is chosen, 21.5, closest to emmetropia, slightly myopic, but still very close to 0. And the K index, so the K index is something that you need to choose based on the keratometer that you're using. So in this case, I assumed it to be 1.3375. So there are other options here. You need to choose the correct index based on the keratometer model that is being used, right? And then choose either plus or minus cylinder to be shown up as your results here. So in this case, I chose plus cylinder. All right, so plus cylinder, so it shows me the results in plus cylinder format here. So as you can tell here, the correction of the astigmatism, right, using ZCT 150 or ZCT 225, right, gave you the closest results, right, to what you want to achieve. Now, how do you interpret the results here? So remember what I said about plus or minus cylinder. When you choose plus cylinder, this shows you the results in terms of the steep axis. Alright, so if you're choosing ZCT 150, the residual astigmatism is going to be plus 0.43. Okay, so that's quite a lot of reduction from what it was previously, 1.62. Going down to 0.43, right? The steep axis is now at 22 degrees, okay, 22 degrees. So if you look at before surgery, the steep axis was at 19 degrees. So it's really close. The reason why it shifted slightly is because your incision, where it's placed, has induced some astigmatism, and because it is not exactly at where the primary axis was, it's going to shift your axis slightly. Right? It's going to shift your axis slightly. So rather than it being 19 degrees, it's now changed to 22 degrees. Okay, so this result shows that the astigmatism is quite, the axis of the astigmatism remain unchanged, right? Because the steep axis at 22, steep axis at 19 means that the incision, the axis of the astigmatism remain unchanged, but the magnitude of the astigmatism has gone down. Okay, so that means if we look at the result here, right? So Remember we chose the spherical equivalent power, 21.5 diopters, right? But the result is minus 0.09. So that means the midpoint, right, is slightly myopic and at minus 0.09 diopters. So it's about, so if I just draw the line just a little bit this side, right? So slightly myopic is the midpoint, right? Because it's a 21.5 diopter lens. Now, when I correct the astigmatism, so I'm bringing the astigmatism down from 1.62, bringing it down to 0.43. All right. So what happens is that the two focal points are going to be much closer now, but the gap that you see between the two focal points, right, is 0.43 diopters. 0.43 diopters. Okay, so we have narrowed the gap from 1.62 to 0.43. So that's not a bad result, because if it's less than 0.75, that means the patient is going to see pretty good. Now the other option here, if you're choosing ZCT225, what shows up here is that the IOL model will create an axis flip. Okay, so what that means is that you're going to switch the astigmatism axis. Okay, so if you look at the residual astigmatism here, it's much lower. It's 0.07. So the amount astigmatism is actually much lower than the choice up here, right? But what happens to the steep axis? So now the steep axis is at 112 degrees, right? Because this is a plus cylinder, right? Steep axis is at 112 degrees. So when you compare it with the original astigmatism, the steep axis is opposite. Okay, so that means it has changed the axis of the astigmatism. Okay, so what that means is that in terms of the correction that we're getting here, okay, we are getting the 2 points much closer together. Okay, so just think about this as much closer. It's just 0.16, right, diopters. Okay, so it's much closer. But what happened is that because we have corrected it so much that the two axes has exchanged places. So the focal point that was on this side here has now shifted over here, and the focal point that's on this side originally is now shifted over to the other side, right? Because there is too much correction, that's why it resulted in a flip in the astigmatism, right? A flip in the astigmatism. Okay. So the result here, there's always a preference, right, on the surgeon. They may choose not to flip the axis. Some surgeons may choose this option because it has the least amount of astigmatism, which they think it's better for the patient, right? So they want to correct the least amount astigmatism as the priority, right? So some surgeons would choose this. Right, so there are other considerations as well. So sometimes in terms of correction, they may look at the original spectacle correction. So like for example, they may look at the original correction of the spectacles, and they want to see how much is the astigmatism actually correcting? Is it fully correcting or not fully correcting what is the actual amount of astigmatism? So if the spectacle correction was not fully correcting it, they may choose not to fully correct the astigmatism, right? Like this, right? So the other consideration is the shift in astigmatism. So generally what happens is that most patients start with the rule astigmatism, and as they age, it drifts towards against the rule astigmatism, right? So so some surgeons want to leave a little bit of with the rule astigmatism, right? So that as the patient age and it drifts towards against the rule, the astigmatism neutralizes itself. So some surgeons would take that into consideration as well. So sometimes you hear about doctors saying, I prefer to leave a little bit of with the rule astigmatism in there, right? So that is one of the reasons why they would choose to do that. If you look at this case here, the steep axis is at 19 degrees, so meaning that this is already against the rule, right? So this is showing against the rule astigmatism, right? So in this case, if the patient is already very elderly, this may have already been shifted to against the rule. So they may not consider this for this patient, right? So for younger patients, they may consider that. The other thing to consider is posterior corneal astigmatism. So when you choose posterior corneal astigmatism here, what it does is that it incorporates the PCA into the calculation, right, to create that. So when you talk about posterior corneal astigmatism, we're talking about an average of against the rule astigmatism of 0.3 diopters, right? So if you look at the original astigmatism, it is against the rule. Now when you add posterior corneal astigmatism against the rule to what was already against the rule, the total amount of astigmatism required for correction is much higher. So that is why you see here, previously without PCA, we were overcorrecting the astigmatism, but when you include PCA, we are now not overcorrecting it. We are slightly undercorrecting it with the same ZCT225 lens, right? So this does work, right? So the good thing about the new calculator website is that under the preferences support, you can choose to turn this on by default, right, or turn it off, right? So if your surgeons are mainly using keratometry readings without measuring the posterior corneal astigmatism, you may want to switch this on, right? Because oops, it took away my calculation, right? So if you are using instruments that do not measure posterior cornea, then you may want to turn this on, right? But if the surgeon is using instruments that include posterior corneal astigmatism, then you can turn this off, right? Because whatever you input as your K readings here, all right, you would have assumed that it has taken posterior cornea into its consideration, right? So some instruments, like I said earlier on, some OCT instruments like your IOL Master 700 does have the potential to measure posterior corneal astigmatism. Some shine fluid imaging instruments, right, like Pentacam or Galilei, they can include posterior cornea, right, or some kind of topography, like the one from Bosch and Lomb, I think they're using, it's called the Xioptics. That what is the instrument called? The Bosch and Lomb instrument for measuring cornea. Right. Anyway, there are some topography that can offer posterior corneal astigmatism measurement as well.